Okay, thank you to the Society for the invitation. We're happy to be here. The discussion, obviously I missed yesterday, and I've been caught up a little bit by Pete and some of the other folks. But hopefully this fits in, and you won't find anything that's completely off base from what you've heard so far through the conference. What I'm trying to get across today is how we're taking computers and the information technology age and bringing it into the cockpit. Obviously, you guys have been talking about that all day long, but we're looking now starting from the year 2012 going forward, and how we're going to insert that technology into the airplanes with the human pilot in mind. In my mind, it's always good, a little bit of a history, to go back and see how we got to where we are today, why the airplanes look and behave the way they do today, and what happened when there were rapid technology insertions throughout the last 110 years or so. I'll talk about what happens when things go wrong as far as inserting technology without keeping the pilots in mind, the human nature in mind, and then some recommendations on how to take that forward. Of course, in the very beginning, there was no cockpit. It was unless riding a bicycle was a cockpit, and the airplanes were not what we would call today practical. They were research airplanes. The cockpit was an outdoor item, and there was, when it comes to aviate, navigate, and communicate, about the only thing you could do was the aviate part. It took 100% of your attention, was just keeping the blue side up. As things progressed through the war years and the intra-war years, first we moved the cockpit indoors. Then we added instrumentation because we found that we wanted to fly inside clouds. And as far as instrumentation, in addition to airspeed, altitude, and attitude, we wanted it to have at least some warning of when the engine was going to quit, because it was going to at some point. But that was really, it was an evolution in technology, and the operations were ahead of the technology for the most part. Of course, then the jet engine comes along, and that's what I refer to as the first revolution in aviation. We went higher, faster, farther in such a short period of time that the machine's performance got way ahead of operational concepts. And of course, the Century Series fighters were, in my mind, the best example of that, because we killed more people flying the airplanes than they were ever intended to kill them from the other end of that. And it was because the operations didn't keep up with the performance, and the amount of data or information available to the pilot in the cockpit would never possibly allow them to do that anyway. So there was a lesson to learn here of what happens when you have a rapid insertion of new technology into aerospace vehicles. Of course, ultimately we went, by the time I was born, we'd gone well into the hypersonic region, albeit with rocket-powered airplanes. But it was routine to exceed Mach 2, at least within military. Now the flight deck, the one on the right side, that's an early model 707. Really, other than there were more round dials, it was essentially the same technology that we had in the early 1930s. However, as we're going faster, and things like the Blackbird, the demand for information it increases at an exponential rate, but we're still getting data at the same rate we were before, and so there's more workload put on the pilot to figure out where he's going next, how he's going to get there, and what the hazards are between there and where he's going to go to. So the bottom line was the basic flying of the airplane was still the majority of the task, and it was in some respects left to chance what happened after that. Of course, the airplanes got bigger as well. We approached practical size and endurance limits. One thing I hadn't mentioned before was one of the answers to that was to put more people on the airplane to divide up the task. And so you always had, anytime you have one or more people in a machine, you're going to have cockpit resource management, your NOTEX. However, there wasn't I wouldn't say it wasn't there and it wasn't taken seriously, but it wasn't as regimented of a part of the training program as it is today. We've come a long way in the last 20 years regarding that. Of course, the three pictures at the top there show the extremes of size, speed, and duration. But again, the data in the cockpit hadn't changed. You got the Concorde cockpit on the left and that early 707 are repeated here today. Those two flight decks are separated by nearly 25 years, but they're virtually the same from the idea of what information the pilot can glean from it. So at this point, all we've done with the technology is improve the performance. Of course, that's what the customers are asking for. Then we had a technology revolution in the early 1970s of the digital computer. So, of course, the aviation industry starts to look at that and says, well, what are you going to do with those? Well, the mindset was still, I've got these high-performance vehicles that are difficult to fly in the first instance, navigating, communicating, we'll worry about that later. So they stuck computers in the airplane to help them fly better so that I can get that performance without any of those handling qualities issues that we always had to deal with in the past. And of course, by the time we got to the 5th generation, we stopped putting computers on airplanes and started putting wings on computers. And we basically solved the aviating standpoint, part of the problem, wherein we have an airplane that either does everything the pilot could possibly desire to do, as you see on the left. It's the airplane every pilot since Orville dreamed about, or on the right where you can completely remove the human from the vehicle itself, and it can operate it at a very great distance, both in time and cognitively, where there is no pilot in the loop of the airplane. You say, hold here, it holds here. You say, take off and fly to that aerodrome, it takes off and flies to that aerodrome. So, aviate, check, it's done. Nothing to worry about, right? I'll come back to that later. So, the computer age then allowed us to start worrying about navigating and communicating and how we can help the pilots in that regime. Because it's just as important over the long haul from the overall mission perspective, even though in the short term it's not as critical. You have to aviate before you can navigate. You have to navigate and communicate at the same time after that. We got a text back there that talks about situational awareness. Really came from good CRM. And as I mentioned earlier, good CRM had yet to really be well defined in the aviation community. We knew it was. We knew when we didn't have good CRM. Let's put it that way. This slide is just up here. Make sure we're all singing from the same sheet of music at what amounts to good information that helps situational awareness. Ultimately, the goal is good decision making. And of course, bad information, which could be overwhelming data, leads to bad decisions. So step back one more time, 1997 versus today. Most types in the transport world were still flying with round dial engines. There were some CRTs on there. The communications were such that you were still dealing with most parts of the world with stale weather information, stale aerodrome information. Basically, you found out what the weather was when we got there in certain parts of the world, although it was improving. Versus today, and I've got a whole laundry list of what the capabilities are of our current flight deck, but it's all happened within the last 15 years to where we've taken data, we've got reams and reams of data that we try as we build these displays to turn it into information that is easily accessible and easily interpreted by the pilot without having to make a lot of mental gymnastics as he goes about it. So the bottom line is we've got a completely paperless flight deck. I can instantly know what the latest weather and the aerodrome hazards are of any airport in the world that I want to go to. And I can communicate from any point on the globe with anybody I need to anywhere. So situational awareness is there for the taking. The question comes, how do we train the crew to use this? And and from our standpoint, how do we design this so that it takes into account human nature? Again, the technology's changed in 10 years, but human nature hasn't changed in 10,000, nor will it 10,000 years hence. So we need to catch the operational concepts back up to where the technology is today. One final note, this second revolution of aviation, unlike the first, where jet aircraft, high-performance aircraft were still multi-million-dollar machines and accessible to large corporations and governments, I can go out and hire or in some cases purchase my own Cessna Corvallis that has essentially the same information, although it doesn't have the international communication capabilities, but the display of information is virtually the same for a tiny, tiny, tiny fraction of the price. So the navigate, communicate, we solved in 15 years. The aviate part took about 80 years. And what we ended up with was, at the same time, we also solved the problem of the reliability. The bottom line was emergencies started to happen much less often than they did before. Of course, human nature is we're designed to notice the abnormal, the unusual. We pick up motion faster than we pick up anything else, and we're not good at monitoring systems. So it's natural to make the information systems monitor those things and tell us when something goes wrong. Of course, when nothing goes wrong, and the airplane's easy to fly, I can talk to anybody I want to the point where I don't want to talk to anybody else. I'd rather turn the radio off. And the airplane never breaks. Well, then you set yourself up for a complacency type of situation, which I'll get to on the next slide here. The bottom line is we've, in some cases unwittingly, transferred the workload to just monitoring the automatics, which are flying the airplane and doing a lot of the navigating for us. And the pilots have stepped out of the loop where they used to be immersed in what was going on the cockpit. However, the responsibility for the decision-making, responsibility to complete the sector, it still rests with the crew and the captain in particular. So one more slide on complacency and how it kills, but how the fact of the matter is it's human nature. So we have a case where the computer always flies the airplane. It always knows where it is and where you told it to go, and it takes you there in a very reliable fashion. And it also reports any unusual events to both you and to your op center or the manufacturer, wherever you want the message to go to. So here we are tuning out the routine, but that's all it is on the flight deck is routine. So how do we bring the pilot, the crew, the captain back into the flight deck where he's immersed in what's going on? A sidebar on the next generation of pilots. Has anybody seen a 20-something, or a teenager, no less, who has not, from morning till bedtime, had a personal electronic device in their hands? I mean, if you're under the age of 20, you take it as a fact of life that it's always been there, and it always will be. So when it comes to training, we need to take that into account. This generation of people are going to be very comfortable, very familiar with this type of technology, information technology, displays, communications. And the good news is they'll learn very fast if we design the system the right way, okay, to present the right information at the right time in the right way. However, when you drop your iPhone out of the pocket and it hits the pavement, there's no cost to life or limb. So one, it rarely happens, but two, when it does, it's no big deal. I go down to the Apple store and I get another one, right? So they can be complacent about what the technology can do to them, especially with respect to an aerospace vehicle. They will also expect little or no training to be necessary. They want to be able to get in the airplane, kind of like we heard earlier, they open the iPad, oh, there's a manual, that's very interesting, thank you very much, let me plug this in and start surfing the net with it. And frankly, there's going to be that expectation in the training programs, and it'll be up to the trainers to instill some flight discipline in the crews from the very early stages. Remember, I showed you the picture of the Corvallis. You can get the flight schools can buy a Skyhawk or a Cirrus with exactly the same flight deck on it. And so from the very beginning, pilots have a giant PFD in front of them that's tied to AVARs and GPS. The work's done for them. The training, because the airplanes are really computers with wings, the training's going to be done by computers too. So it's going to be important that as we design the training devices as well as the training programs, that we make sure that the training is oriented towards the human experience and human nature, not towards the computer. I will say you can never know too much about your airplane. And as a test pilot, I believe that. Operationally, what I'll say is, the only thing I'll use to qualify that is you have to prioritize what you need to know. Okay, you start at the top with how the airplane behaves under normal circumstances, how it's going to behave with System A or System B failed, whatever failures that you can envision, let alone quantify how often they're going to happen. how many rivets are in the left wing? Who cares? How many pumps are in the right fuel tank? I don't care. I want to know what happens when it stops working. Okay. So and then once you know all that and you're comfortable with it, maybe in your 20th year on type you can start to learn some of the other stuff. That's what I wanted to point out there. So what we want to try to do is catch the pilots up to the technology as we're basically the dust is starting to settle on this second revolution of aviation. Training must still emphasize the non-normal. I think that goes without saying. The point I wanted to make out of this slide, though, was that the technology is presented to us in a very reliable, very easy to understand fashion. If we design it properly, what we need to do is be able to know what that airplane is going to do if something were to go wrong. And I need to know what my capabilities are, and I need to know what the airplane's capabilities are. We're never going to come to the day where everybody is a Sully Sullenberger and he hits 14 geese on departure and has a wide open Hudson River, thank you very much. But the passengers were all happy to know that he was comfortable with that situation because of his skill and his ability to talk to the people both sitting next to him and on the radio outside of that. And the situation was handled quite remarkably. I'd like to say everybody should go back and fly as steerman, but those days are gone where we need to spend a lot of time learning to fly the nuances and what we call in the test pilot world in design is compensation for the bad characteristics or the features of an airplane. We fixed all of those, but you still need to know how your airplane's going to handle for a given situation, and you need to train to those situations so that it'll give you the confidence that you know what's going to happen and that you're capable of it, and then also you know the capabilities of your airplane once things start to go wrong. The human-machine interface is really where the challenge is today for designers, and it applies to the trainers as well. And in fact, it can make things worse. I'm picking on Bill Gates here in Microsoft Windows, but that type of thing does indeed happen on flight decks, although rare, and the crew needs to know what to do when you get, again, complacency sets in. I've got all this data, all this information, it's sitting there, but think, well, what happens if all of a sudden it disappears? Okay, how do I handle that? Or how does the machine reconfigure itself such that the pilot can still maximize the utility of the airplane to safely return to the earth? One thing I'll point out on this, or a couple things. One, engineers don't think like pilots, and pilots don't think like engineers, because they don't move through space and time on a regular basis. They don't have an office that flies at 450 or 500 knots. They're sitting there 0 knots, 1G, 20 degrees Celsius, surrounded on 6 sides by walls. So things make sense to them, but in fact, they don't work in the real world. So you have to have pilots involved from the very, very beginning. And you have to stay engaged throughout the entire design process. The other thing, computers being only able to do what they're programmed to do, they're not flexible, they're not creative, and they can't make decisions. All they can do is input, output. This happened, oh, well, I'm supposed to do this. And like I was mentioning a moment ago about reconfiguration, well, a certain input fails or a certain amount of electrical power goes away, well, okay, well, I'm supposed to do this then. Well, it does that. Of course, the pilots are trained to that, I'll call it predictable behavior. And it's up to us to make sure that what is then presented to the pilot is still what he needs to know based on the reduced capabilities. Okay? Humans are not good watchmen for this, so the computers, what they are very, very good at is telling us when something is going wrong. And typically, we're getting to the point where they can tell us before it's gone wrong that, hey, in the next 5 hours, the next 10 hours, the next 10 calendar days, this is going to go wrong on this airplane. We're getting to that point now where we can predict failures. Also on this slide, I want to start transitioning to what I'm going to go on the last handful of slides I've got here is the automation that sits on top of all of this information technology. It's supposed to reduce the workload, not transfer the authority or the responsibility away from the pilot. Okay, and I think that's where we lag the most. Is we're taking the automation and we're using it to replace some of what the pilots have done from a decision-making standpoint. and we need to get the pilot back in as the decision maker. And the reason it's gotten so important is we talk about what we call control authority. Now, the captain has complete authority to do whatever is within the operational flight envelope of the airplane. He physically has that control of the airplane. We have now got automated systems that have more capability to change the vector of the airplane or the configuration of the systems on board the airplane than the captain does. And would you put a co-pilot in the right seat that is not creative, cannot make decisions, and only can react to a certain situation in a very rote way? Would you put him in charge and give him that kind of responsibility? So that's what we need to guard against here with the automation. It's a handy tool, but it's really part of the crew because it's doing some of the tasks that we ourselves are still responsible for and always will be. We can make it too complicated too. As we design these things, one of the first things we need to do is allocate each individual task and subtask, clearly define it, and then allocate, well, this is going to be part of the computer, this is, it's a task it's going to do, albeit not in an automated way, and then sit on top of that, well, this task is going to happen through the automation. And then, of course, there's things that we need to keep the pilot completely in the loop on and make him take the action, make him make the decisions. Because otherwise, we get back to the complacency problem on the one hand, and we give authority to something that's frankly not qualified, doesn't have the skills to take that authority on in the second hand. Some rules that come in the operational world: if a piece of automation isn't reducing your workload, then stop using it. And as an OEM, if we start to see that as we go, we try things in research and development, and if it's not meeting that goal, which is the only purpose of automation, then we remove it from the design. Same thing, the worst case, if we have automation that's actually forcing human errors, then stop using it immediately, and then make sure we head in another direction from a design and technological standpoint. But we can be our own worst enemies, and the insertion of technology just for the purpose of technology is typically not a good idea. So I've kind of talked to what's on this slide already. The only other thing I did mention was a lot of times we respond to customers and, hey, wouldn't it be great if the flight management could do this, or wouldn't it be great if my synoptics place for the systems could do that? Well, we always aim to please because they're paying customers. What we find, though, is a lot of these things, especially if they're scabbed on after the fact, after we have a core design that was built from the ground up, they're buried deep in the box, and they're difficult to get to. They're complicated, which means they require a lot of training and a lot of attention towards something that's a nice-to-have feature that the pilot is now sitting here looking at this 18 pages deep in this computer display when who's minding the store for the overall operation of the airplane that's still moving through the air at 9/10 the speed of sound. So we have these three rules, and that I see in the text box there at the bottom for an automation feature. And if it doesn't meet all three, then it doesn't go in. That's where we're heading now. So to wrap it up, I've got some recommendations that we are inputting into our own basic designs. And it starts with the human-machine interface is the key design feature going forward. The machines, as you heard earlier, are much too complicated for any one individual or crew to know everything there is to know about it. But we need to know what its behavior is going to be with or without any one of those components or any number of those components. So we need to design the machine side of that to make sure that the pilot has the information he needs, only the information he needs, and is doing only those things that are strictly rote. Event A happened, I will do response A, right? And then tell the pilot about it before I do it, or as I'm doing it. Again, you saw that earlier, I think it's important. Automation has a lot of authority over what the airplane does and where it goes. So we need to treat it like a third crew member, and it needs to practice good CRM as well. So that the technical stuff needs to be non-technical. We need to know technology is still going to outpace everything else for the foreseeable future, so we need to be smart about how we insert it into the airplanes and how we train the operators to handle it. Again, the flight deck needs to revolve around the pilots, not the other way around. Of course, pilots will be happy to hear that the airplane revolves around them, just like the rest of the world. But the automation is now going to become one of them, albeit a junior partner. Train the pilots for the things that only they can do. It's going to be a long time. I don't know if it'll happen in my lifetime where the computers really can apply common sense in a creative way to solve a problem that is not a simple input-output type of situation. So the pilots never forget the basics. Keep your piloting skills. It's a lot easier than it used to be because the airplanes, frankly, don't have a whole lot of poor handling qualities now. So when you go to the simulator, practice flying the airplanes when things aren't in tip-top shape. Because when everything's working fine, it's a breeze. You can put your 10-year-old in there. It's when things go wrong. Those are the things we need to practice. And then how to make decisions under those type of high-stress situations. That's the other half of that. Understand this gets back to knowing everything you can about your airplane. Understand what the avionics can do to the airplane. And by that I mean at the very basic level, what can they do to where this airplane is headed in space, the vector it's on? What can they do to the configuration of the systems on the airplane? We have software and with a full authority digital computer on engines. There are software modules in there that can turn the engine off whenever it feels like it. Now it's programmed to do it only under certain events, but you'd be surprised how many operators do not know that exists in every major large turbine engine today, software to do that, okay, for a number of reasons. Same thing with flight controls. The flight control computers will reconfigure the airplane based on certain failures, an input, and now it'll warn the pilot. We're working on being able to warn the pilot ahead of time. That it warns the pilot as it's doing it, and I guess it gets back to what I mentioned earlier about the training. You've got to make sure that the pilot knows what's going to, or knows how the airplane's going to handle once those events happen. The automation, the automation needs to be kept simple so that it's a straightforward, easy process for them to learn how to use the automation. It shouldn't take 4 weeks to learn how to run a flight guidance panel. Okay, it shouldn't take 4 weeks to learn how to run the functions and features of an FMS. It should be presented in a straightforward, unambiguous, and intelligible way to the pilot. Says, oh, this is what I want to do. Here's the button I push to activate that feature or program it, and off you go. Kind of like we want to have a Steve Jobs of the flight deck. Okay. So as we go through these things, every time we make a new airplane, we need to keep the mission and the operational concept in mind every step of the way as we build up. We start at the top with the mission, and then we work our way down into details, and then we build the airplane up from those detailed requirements, and checking ourselves every step of the way until we get an airplane that's entering into service, and we present it to the authorities for CS25 certification and the OEB for operational suitability, and then on into what we hope is happy customers that have an easy to operate airplane with a third crew member. I think with that, I'm exactly out of time, and we'll hold questions until later.
Scott Martin, thank you very much. A fantastic insight into the issues of designing a modern aeroplane. What those avionics, fantastic. I don't know if the back of the room you can see some of those superb Gulfstream avionics that are displayed here. Absolutely wonderful. And of course your recommendations for dealing with automation were spot on. Right, 2 out of 3. Third speaker,